All right, so today's video, we're going to continue factoring polynomial equations, but we're going to use algebra tiles to factor some expressions that are slightly more complex. So the first thing we need to review is where we've been. We know that we are solving polynomial equations, and polynomial equations are just equations that are made up of polynomial pieces. Now, when we're solving those polynomial equations, like we're reading here, we have to have them in a special form and able to use the zero product property. In other words, we need to have them in factored form. So if we look at the examples that we have, like example number 1 right here, that's not in factored form because it's not written as a product. Same thing with example number 2 right here, it's also not written as a product. So for both of them, we would need to rewrite them. And what we studied in the last video was using the GCF. Now, if you don't know what the GCF is, you should go back and rewatch that video. So right now with this one, what I would be able to do is I'd be able to factor out the GCF. So the greatest common factor between 4 and 16, well, that's a 4. And the greatest common factor between x squared and x is just x. So after I rewrite this, which would just be x plus 4, now it's in the correct form. We have a product of two things. So I'd be able to use my zero product property to solve and find the possible values of x. But what we're looking at today is what happens if there is no GCF, like example number 2. What I notice is the numbers 1, 7, and 12 don't have anything in common, and not all of the terms share x's, so they don't have any common x's. So what we're studying today is what do we do if there isn't a GCF? Now, what we're going to use for today is algebra tiles. Now, here's just a list that you have in front of you from notes that I gave you in class about how we do this. So the general idea is we're going to be given an expression. So in the picture I have to the right, we were given the expression x squared plus x minus 6, and the directions would be to factor that. So in other words, I want to rewrite that as a product of two other things. Now, what we're going to do is we're always going to make a rectangle, because a rectangle helps us understand that one of these things is the length and one of them is the width, as we can see in this picture here. So what we do is when we're given an expression, we need to make a rectangle that would represent the area of that expression. So if the expression, again, is outlined here, x squared plus x minus 6, what I notice about my picture on the inside is maybe it's not simplified yet, but when I do simplify it, it does represent the same expression. So once I have a rectangle whose area is the same as the expression that I've been given, then I can find the dimensions of that rectangle. So we can see one of the dimensions right here was x plus 3 long, and the other dimension right here was x minus 2. So this would help inform us that the way to rewrite this would be x plus 3 times x minus 2. Now we're going to learn how to do that, but here's some quick tips that as we go through some examples that I want you to keep in mind and watch out for. The x squared tiles always go in the corner where our horizontal and vertical lines meet. So what I mean by that is we have this vertical and this horizontal line right here, and that's just for organizational purposes. But what I want you to notice is that right where they meet, those where my x squareds go. With that, wherever you put your x squareds, your 1s are always diagonal from that. And I'm just watching out in case like some of you might be drawing pictures like this. So if your x's meet down here, then this is where your x squared would go. And then kitty corner to that, this is where all your 1s would go. So keep that in mind. We'll see in one example today, we might need to add some tiles, but we'll get there in a moment. But some big things when we're creating our pictures is keep all the positive x's together and all the negative x's together. So we should see on our picture right here, all these positive x's are in the same place, and all of these negative x's are also in the same place. So just some tips to keep in mind to help you interact with making these pictures. And then finishing up, as we can see, once we make our rectangle, we have our dimensions for our factored form. So we're going to go ahead and do an example. And this first example is going to be a situation where the expression that we're given, x squared plus 3x plus 2, is going to contain all of the tiles that we need. So just like the easiest example. So what I have prepared for us, I have this little algebra tile app here. You can just be using algebra tiles in front of you, or you could be drawing pictures. Now what we need to do is we're just going to get that expression in there. So I'm just going to show what our expression is. So we're trying to factor x squared minus x minus 6. So what I need to do, or excuse me, starting with the first one, x squared plus 3x plus 2. So I'm going to get those pictures or those tiles on my picture. So I have an x squared. I'm going to bring in 3 x's. And then I'm going to bring in 2 positives. Now, just going through our list of steps, I can see that my organizational line is here and there. So they meet right here, which is indicating to me that I'm going to put my x squared right where they meet. Now, from there, directly kitty corner to that x squared is where I should put all my little 1's. Now, I do not know how to organize the 1's, if I should make it 2 long by 1 tall or 1 long by 2 tall. We'll have to guess and check a little bit, but once I set those up, I want to take the remaining pieces that I have right here, and I want to somehow fill in a rectangle. So what I can just quickly show you is if I put maybe an x there and an x there, and maybe if I flip that x the other direction, I now have a perfect rectangle. So to find how I factored this expression, right, so it represents the expression we're given. You can see that right over here, over on that screen there. Now, what are the dimensions of that rectangle? Well, we know that this little side here is x, this little side here is +1, and this little side here is also +1. The long side of this tile is an x length, the short side of that tile is a +1. Now, if you want to, you can also go ahead and just use more algebra tiles to help you find the dimensions. So I'm just going to fit algebra tiles along the side here. So like an x tile would fit there, a 1 tile would fit there, and a 1 tile would fit there. Just like over here, an x tile would fit there. Oops. I'm going to be writing all over that. And then a little 1's tile would fit right there. Just think there, snap that in. So what I've seen now is the dimensions, x plus 2, this length, and this width, x plus 1. If I multiply those together, x plus 2 times x plus 1, the area it creates is x squared plus 3x plus 2. So I've successfully rewritten the original polynomial in factored form. So our answer is this. So if I write it here, this would be x squared plus, our answer is just x plus 2 times x plus 1. So on your notes, I would just draw that picture so I know that you watched this video. So let's go ahead and look at the next example. Now this next example here is an example where if I just put this expression on my algebra tile, so like if I get an x squared, a negative x, and then 6 little negatives, what I see in this situation is the tiles that I started with. So if I go ahead and put my x squared tile where my vertical and horizontal organizational lines meet, and then I have to go ahead and put the 1's diagonal to that. Now again here, there's just more of them. I don't know how to organize it. I don't know if it should be a 3 by 2 or a 2 by 3, or I guess I could do a 6 by 1 or even a 1 by 6. I'm not quite sure how to organize those, but I want you to see that no matter how I choose to organize those, I'm never going to have enough x's to fill in all of those spaces. So we have an example here where I don't have enough x's to complete my rectangle. Now the idea here that we're going to do with that, as it was stated in our notes here, is we might need, I'm just highlighting where you would be looking, we might need to add positives and negative x's to our picture. So what I want you to notice here is that like right now the area that I have is x squared minus 1x minus 6. On my picture though, if I put a positive x over here and a negative x over here, my area doesn't change. When I simplify this, I still get x squared minus x minus 6. So the idea here is if I need more pieces, and I'm going to write this down on the note so you would write it down too, the general idea here, when that happens, if the expression doesn't contain all the tiles I need, what we're going to do is we're going to add pairs. 1 positive x and 1 negative x. So for example, with this, I added a positive x and a negative x to my picture, and that wasn't quite enough to make a rectangle. But what I could do is I could add another pair of a negative x and a positive x. So if I put that there, and if I put this here, I added 2 groups of pairs, but it doesn't change the area. What I see here is if I were to simplify this area, x squared minus x minus 6. That's still the original problem that we have over here. Now, what I also want you to note is that when I did that, I was also making sure to follow this rule right here, where I'm supposed to keep all the positive x's and all the negative x's in the same groups. So now all I need to do is figure out the dimensions of this rectangle. So I can do it by hand, like this long side is x, this short side is a -1, this short side is a -1, and a -1. So I can see that one of the dimensions was x minus 3. This side here is an x, a short side that's green is positive, and this is a positive 1. So the other dimension would have been an x plus 2. Now, if I don't want to use that, I can also use my tiles to just line up the edges. So an x tile would match up there. These would be -1s. An x tile would go there, and then this would be a positive 1. And I can double check my work. I'm going to go ahead and clear some of this ink off now. I can double check my work using multiplication to make sure that I'm right. What I mean by that is x times x is x squared, -1 times x is -x, and I can see that everything works out. So my final answer here, how would I actually rewrite this as a product? It would be x minus 3 times x plus 2. Now we're going to go through the last example. Now this last example here is combining two things. It's going back and also reminding us that when we can solve equations, we can do that with the zero product property. So we're supposed to solve this equation using the zero product property. Now the first thing we notice about that equation, to use the zero product property, it needs to be equal to 0. So the first thing we're going to do is we're going to subtract 1 from both sides of the equation. So we get 2x squared plus 1x minus 1 is equal to 0. So now we have it equal to 0, but it's not in factored form. So I need to take this, I need to somehow rewrite it as a multiplication of two other things. So we're going to go to our algebra tiles. So we're going to take out 2x squareds. I'm going to go ahead and put them right away in the corners. Now I don't know if it should go there or if it should go there. Doesn't really matter for me. I'm just going to put it here. And then I need 1x, and then I need a positive 1. Now no matter where I put it, these little 1s are always going to go off the diagonal. So if I put it here, my diagonal would be there. If I put it here, my diagonal would be there. So what I'm going to do is I'm just going to try this. So if I put it there, well, I would need a positive and a negative to fill these holes, but I can't combine the positives and negatives, right? All the positives and all the negatives need to be in the same place. But I realize I do have the right tile, so I'm just going to go ahead and take this one. I'm going to flip this over here. Oops, I'm sorry. I'm supposed to have a -1 on my picture. And this is my area. So again, just starting over because I kind of messed up that one time. I needed to factor this. So the first thing I did was I took out 2x squareds. I took out a positive x and a -1. So we follow our rules. We need to put the x squareds where the vertical and horizontal lines meet, either like that or like this. So I chose it like this. And then my -1, or the 1s, always go off the diagonal corner. So from here, what I realized was I don't have enough tiles. So like I put it there and said I would need 2 more long tiles. So if I'm going to add new tiles, they need to come in pairs. But then the next thing I realized was I can't mix up the negatives and the positives together. So what I could do is I could just switch these around. And a lot of this is going to start to be guess and check. But what I realize now is I have a rectangle, and if I simplified the area, these x's would combine just to be 1x. So getting the dimensions of this rectangle, I'm going to use the tiles to do that. This is a long tile, which is a length of x, a length of x, and this is a negative tile. So then this would be an x there, and then this would have to be a positive. So over here, like we've actually factored it then. So the factors are 2x minus 1 and x plus 1, and that equals 0. So now we can use our zero product property. One of these things, or both, could be 0. We need to find the values of x that could make this true. So over here, if I add 1 to both sides, I get 2x is equal to 1. So one possible answer would x equals 1/2. Over here, another possibility for x would be -1. Both of these are